Okay, so I'm going to explain how to choose your restriction enzyme, um, count the band total, and also choose your restriction enzyme needed for orientation, and how to calculate orientation. So the first thing that we do is we choose our restriction enzyme. If we look at the sequence here, we have XBAI, we have SMAI, BSO, BI, HP, and C2. And we need to choose from these which one is the best to use as our restriction enzyme for putting our insert into the vector. So the first thing we look at is if our restriction enzyme flanks the gene. So we want we want to have a restriction enzyme in front and behind of our host gene. If we look here, all of them fit this description except for BSOBI. So now we move on to the second rule, which is we need it to exist within the LAC-Z gene and nowhere else. So if we look at our vector here, SMI exists within the LAC-Z, HP and C2 exists within the LAC-Z gene, and XBAI also exists within. But SMI and XBA, they both exist on the AMP-R gene, which we do not want because if it's properly inserted, it'll disrupt the resistance gene, and those will die once we plate them. So the only one that only exists within the LAC-Z gene and the one we should use for restriction enzyme is HP and C2. So that's the enzyme we're going to do. What happens here whenever we try and insert is HP and C is going to be broken, and the HP and C2s on the insert, they're going to cut out the coast gene, and it is going to insert at where the HP and C2 is on the vector. So I've gone ahead and drawn this. This is what it looks like. So we still have the same distances here between the enzymes or the restriction sites. So like this is still 650, this is still 500. The difference is that now instead of just a single HP and C2 right here, we have two HP and C restriction sites, and we have our area that was in between our HP and 2 sites on the restriction or on the insert. So now we have this. We need to write our distances that were on the insert onto the vector, now our construct. So let's go ahead and do that. We can see that the coast gene itself, which is HP and C, all the way to SMI right here, that was 850. So this distance is 850. Our distance between SMI and HP and C, which is this distance right here, is 50 base pairs. So let's write that in. All right. So this is the forward orientation. We are now going to look at the reverse orientation right here. So in this case, the coast gene is pointing away rather than toward, and we can go ahead and write out the same base pair information that we did for the forward orientation. This is going to be 850, the HP and C to the SMI, and then from SMI to HP and C here, it's going to be 50 base pairs. All right. So now we have to determine orientation, because over here we have forward and right here we have reverse. So orientation is essentially looking at the differences between base pairs between the forward and reverse. So first, let's go over how we choose the restriction enzyme. It has to have polarity. What that means is here is the sequence that we ended up inserting, right? Within this sequence, we need some value to change, and that will be polarity. So we see in the forward orientation, we have 850 and then 50. And then in the reverse, we have this instead. We have 50 and then 850. We can look at that right here. We have 850 right here, and then we have 50 right there. Here we have 51st, and then we have 850. So we have polarity if we use the SMI restriction enzyme, because the location of it, which is this one right here, the location of it changes depending on whether or not it's forward or reverse. And then it needs to exist 2 or more times. SMI exists a bunch. It's here, 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 and here. What would happen if we had a restriction enzyme that did have polarity? So it changed the band or the base pair totals between enzymes, depending on forward or reverse orientation. What would happen if we just had 1 and not 2 is that we would not actually be able to see the bands whenever we did electrophoresis. And this is because if we had a vector or a construct and we cut right here, it would do this. It would still be one big DNA molecule. So these would read the same on a gel electrophoresis because it's still, let's say, like 1,000 and 1,000 base pairs long. They're the same distance. But if we have 2, now we have this piece and we have this piece. So this might be 400 and this would be 600, and we would actually be able to tell the difference whenever we do a gel electrophoresis. So we're going to use SMI because it has polarity and it exists a bunch on the construct. So now let's look at what the band totals would be. And then we'll also look at gel electrophoresis. So what I've done is I've gone ahead and since we're using SMI as our restriction site, I've just made a line where those are going to be cut. It's the dotted line. And so now we have these pieces of cut DNA. We would have one in between these 2 SMI sites. We would have one in between this SMI site and this one. And then we would have another one here to here. And then the last one would be here to here. And what we need to do is figure out the length of each of these pieces. So let's do the top one first. So we have from 850 to BSOBI, and then 650 from that to SMI. So if we add those together, we get 850 plus 650, that is 1,500. And then the next one, we have 500 plus 1,050, which will give us 1,550. And then we have 1,150 plus 700, which is 1,850. And then finally we have, oh, I did that wrong. So it's 1,150 plus 700. And then we also need to include the insert now, this section right here. We have 850 from the insert plus the 700 plus the 150. So 1,150 plus 700 plus 850. We have 2,700. And then from this site to this site, we have 50 and 400, so that's 450. So these would be the band sizes that we would be left with. Let's go ahead and look at the reverse orientation. So most of these are going to be the same. We are going to have from here to here, here to here, here to here, and then there. We're still going to have the same amount of bands. It's just the sizes are going to differ. So let's start at the top again. We have 850 plus 650, which is going to be 1,500. We have 500 plus 1,050. So we have 1,550. And then we have 1,150 plus 700. And then this time, instead of having 850, we're adding 50 because it's the reverse orientation. We're just taking this distance here, plus this distance here, plus this distance here. So 1,150 plus 700 plus 50 gives us 1,900. And then now we have 850. That's this distance right here, 850 plus 400. That gives us 400 plus 1,250. Okay. So our answer, if she was to ask what would the reverse and forward orientation band sizes be, is we would just list them. We would just say 1,250, 1,500, 1,550, 1,900. And yeah, we would do the same thing for the forward orientation. If she asks us to either identify whether or not this gel that we ran is forward or reverse, or if she asks you to draw the gel electrophoresis, this is how you would do it. So let's say that this is our forward. This is where we put our forward results, and this is where we put our reverse results. So for our forward, we're going to have a 450 band. So let's go ahead and draw that. Right here we have 250, right here we have 500. So 450 is going to be in between those and closer to 500. So we'll have a band here. And then we have a 1,500 band, and then a 1,550. So it's going to be extremely close. And then we have a 2,700. So in between 2,000 and 300, closer to 3,000. So like that. That's what our forward would look like. For reverse, we have our lowest is 1,250. So we're going to put that right in the middle of 1,500 and 1,000. And then we have 1,500, which will be there. And then we have 1,050 again. And then we have 1,900, which will be right underneath 2,000. So what she might do is ask you to put them here, but she could also go like this and ask you to identify, given these results, is the insert forward or reverse orientation. That's something she could ask. That is basically it. If you have any questions, just text me on the group me. We also have practice problems on my practice test and the one that Alice sent. Those are two different practice questions. So just let us know if you have any questions. Good luck.